Good afternoon to you. Mark Sott with HurricaneTrack.com here with your hurricane outlook and discussion for the peak day, September 10th, the peak of the hurricane season, the climatological statistical peak, whatever that means. Here it is. And right on cue with that peak, you would expect to see activity in the tropics. Now, while we don't have any hurricanes out there currently, we do have plenty of systems to keep an eye on, a lot of energy lined up here in the deep tropics. This is the remnant area of what was once Gabrielle. Well, I guess it still is, but it's post-tropical now, way up in the cold waters of the North Atlantic. And if we look at the tropical weather outlook, this just updated a short time ago. 3 different paragraphs here. The main one that I want to focus on today is this one right through here, showing 30% chance over the next 5 days. I believe that number will go up, and I'll show you why I think that in just a moment. We do have a couple of other systems out here to watch in the Atlantic, but things are just kind of slowly progressing right now, which is obviously great news. We don't need anything after Dorian coming along and smacking us all in the face once again, but it's only a matter of time, I do believe, and I think we're going to have a very busy time through the rest of September, and then getting really busy with the possibility of some major impacts into October, probably even into mid-October. And the peak of the hurricane season does last well into October. Today, this update here from the Hurricane Center from Hamrick and Blake. Sounds like an attorney group, right? A law firm. The law firm of Hamrick and Blake. Anyway, I don't know who Hamrick is, but I do know Eric Blake, a fine gentleman. He has a daughter with the same name as my daughter, for what it's worth. All right, moving right along. So the stage, as it were, is set. And I want to emphasize this pretty strong today, that, and especially when I show you this compared to last year, this is the sea surface temperature anomaly. It updated yesterday. It was actually late in the day that it updated, so I didn't include it in my update yesterday. But look at what we have going on here in the tropical Pacific, this La Nina type. I mean, it's more neutral, but it's got a La Nina look. Certainly not an El Nino. We lost all that heat in the equatorial Pacific, so there is no El Nino, no assist from rising motion necessarily down in the tropics anyway, to create shear coming across and sinking air over here. I think that's just gone. I mean, you're going to have these periods where, yes, we do have a suppressed phase of different intraseasonal phenomena, but there is no El Nino, so we put a big X sitting out here. Meanwhile, in the Atlantic, look at the main development region all the way over from Africa to Central America. Every bit of it is quite a bit above normal overall. And the North Atlantic is as well. Gulf of Mexico right where it should be, generally speaking, but it's almost always going to be warm enough to sustain intense hurricanes. And then you see the wake left behind over here from Dorian, and those water temperatures have cooled off just a little bit. They will rebound, and there is still plenty of upper ocean heat content, believe me, to take advantage of if a hurricane comes along. Now, when we compare this to last year, I mean, come on, look at that. There is no comparison. I mean, there is, but that's why we're comparing it, but it is quite a big difference. Much warmer in the deep tropics overall now than we saw last year. Now, last year we had this very, very warm water relative to average way up in the subtropics, and that might have helped to fuel that really strong ridge that eventually got Florence to come in and do what it did. North Atlantic warm this year, but a lot of energy now focused down here in the deep tropics to fuel low pressure, an overall signal that we really need to pay attention to going forward. And in fact, if we look at some of the different data sets here, this is the NOAA-NESDIS data set. If we look at the CDAS data, and these are just different ways of assimilating the data, it's generally going to be agreeable, across the board. So this is a look at the ENSO in the 3.4 region of the Pacific, and generally speaking, we're talking about roughly this area right through here, plus or minus. a few hundred miles, something like that. That's the box that we're talking about, this Nino 3.4 area. Get my blue color back. We'll use sky blue. You know what? Let's use red. There we go. So early August, it was sitting up here. We can just round it up and call it 0.4. All right, this makes it easier. And then look, it just fell off the cliff. Now it's had a little bit of an uptick lately, but the value today is about 1/4 of a degree below average. You know, we went down pretty close to La Nina thresholds there, maybe even surpassing a little bit. But the bottom line, this big loss in heat content in the equatorial Pacific is important because it doesn't. It's a big positive factor for Atlantic hurricanes. That's the way it shakes out. In seasonal forecasting and even looking at the intra-seasonal, weeks at a time, the loss of that heat content across this region means that we really need to pay attention here. It could equal a lot less wind shear cutting across this region, maybe even into the deep tropics out here. It doesn't so much affect the far eastern Atlantic or the Gulf. It's mainly this area right through here. And there you go. I mean, we can see this data both in this graph here, the satellite presentation on the map, and then with regards to the main development region, we have this plotted as well. Levi does a great job with this on his site. Look at what's happened overall. You look at the trend, these ups and downs, but the trend has been up. And now we're sitting at 1/2 degree plus, 0.51 Celsius above average across the main development region. And that is, I don't want to say alarming, but you should take notice of that. And, if you were in the bath and your water was 26 Celsius, which would be kind of chilly for a bath, and you increased it 1/2 degree Celsius to 26.5, you really wouldn't notice that. But across the vast reaches of the ocean here, 1/2 degree Celsius of more warmth is a tremendous amount of extra energy spread over a large area, especially if that ocean is also warm to a depth of more than just the surface. We call that the upper ocean heat content. And this is enough to really get my attention. It really is. And you compare this to last year, the stage is set for a very busy end to the season. Talk about a backloaded season, we could have that. And that's not a guarantee. And I'll just, my real quick sports analogy, just because so-and-so free throw shooter is 92%, they could still miss 4 in a row in some big game, right? That's how statistics work. So the probabilities are there, it looks like, just from looking at things logically and from an atmospheric perspective, that we're going to have a very busy time here over the next several weeks. We're in this little bit of a lull right now. I think that's going to change. And we can see that one of the models here, the ECMWF, this is the Madden-Julian oscillation, and you see that it kind of rockets across the null phase into favoring phases 8, and then eventually it looks like it's going to try to head into phase 1. And what does this mean? It means that a broad-scale upward motion pattern is forecast to unfold for the Atlantic Basin. And I think the modeling will pick up on this even more as this remains in place longer. It's like playing catch-up. We saw over the trend here, the data, that the Atlantic main development region was colder just recently, and now it's had this rapid rise to warmth. And everything, I think, in the modeling will start to catch up with that. I really believe that's how it works sometimes. Maybe it doesn't, but I believe it does. It just makes sense that there's a lag. And it's not even that the model is insufficient. It's a lag in terms of, now you have this big warm water source. It starts to feed back into the atmosphere, lowering the overall pressures across this area. Pressures rising here, you would think. And that leads to changes in how the models pick that up from a day-to-day basis. So the Euro indicating a quite favorable look. And I mean, a couple of these ensemble members are just crazy, getting well amplified. So we'll keep an eye on this. We can watch this every day. And I think we'll show this every day just to keep things in perspective, all right, how things are tracking along. So the tropical weather outlook from the National Hurricane Center, if we go back to the home page and we look at the 5-day outlook here, these are the areas that are highlighted. And then we look at that on a satellite picture here. This is the area that's forecast to become possibly more favorable over here. And then you have these innocuous systems for now lurking in the deep tropics. I wouldn't worry about these areas much at all for the time being. Huge upper level low sitting out here west of the Canaries and south of the Azores Islands. So generally speaking, not a very favorable look in the deep tropics. But you know what? I don't know anybody who lives on land out here, because there isn't any. Do you? I don't. I do know people that live over here. Some of them I've met in person. Carlos, I'm talking about you, buddy. And Brent down in the Virgin Islands. And I've become friends with a lot of these people that I've never met through social media. And this is where it really starts to matter, that you get these systems that come along kind of ghosting, invisible, and then they pop somewhere over here. And while you may not have a long track hurricane coming through, you can still get a developing system like Dorian did, where it, I don't want to put too much, it didn't wreck the Virgin Islands, but it certainly came together going across the U.S. and British Virgin Islands. And then we saw what it did in the Bahamas. And this is where people live. They don't live out here in the open Atlantic. They certainly do in the Cabo Verde Islands. But you get the point that we got to watch these, but even though they don't develop here, that means that they are fair game somewhere over here later on. And this system right here, bad arrow. Let's try again. This system right here, I definitely have my eye on. A lot of energy there. This will move through the southern Bahamas, it looks like. Could bring some rain and more misery for folks in the northwest Bahamas. The fresh water is needed for people that are needing a fresh water supply, as long as it doesn't prolong and you get lightning and gusty winds, etc. It does hinder the recovery process. And then I think this has a chance at developing. If we look at the GFS here from the 12Z run today, one of many global models. It's just, we don't have time to go through all of these. I want to try to make this shorter and more to the point going forward. So in that spirit, let's just look at one model. Now, what are we looking at? We're looking at 5,000 feet in the atmosphere, the 850 millibar geopotential height, and the cyclonic vorticity and the wind speed in knots. What does all that mean? And that's meteorology. And for you and me, the bottom line, keep your eye on this. That's the little weak area, the little surface trough. This is a big sprawling area of high pressure in the atmosphere. And we're looking at spin or energy. And what I am looking for in my work, I've talked about this before, but if you are new to my videos, I'll school you real quick. See how everything is spread out. All this yellow in here is a little bit darker yellows and oranges. It's spread out. It's not concentrated. What does that look like on a satellite picture? And let's zoom in on this. That'll help. There it is. That's what it looks like. Everything is spread out. You don't see any banding. In fact, the upper level winds are kind of coming across the system like that. The energy is not aggregating or coming together, and you can see that represented in the model here. It does a good job of that using satellite analysis usually. But there is a little bit of curvature. You can see that in the height lines here and in the flow down at the surface, or 5,000 feet anyway. The wind, instead of coming along straight, it bends a little bit. So there is a little bit of energy waiting. That's the starting point. So if we move this through time using the slider, watch how it comes through, and it looks a little bit more vigorous. You can see the counterclockwise turning in the wind barbs through here. Luckily, not much activity up in the northwest Bahamas. And we're going to keep our eyes on the folks down there. It's rough. And I think this will avoid bringing too much misery through that region, adding insult to injury there. So you score this out. This is 72 hours, South Florida. And you see here it starts to try to close off there. So a little bit more of a vigorous signature to it. But it has a ways to go. This isn't jumping out at me as like, okay. But I wonder, The models just haven't done that well with cyclogenesis this year. So either the environment through here is just not going to be that favorable, or we see things change, because now we're talking about 90 hours out. All right, if we move it forward, now we're at day 5 right there, and it's a little bit more. I mean, that's got my attention a little more. Larger system spread out, but this is 5 days away. A lot can change in that 5 days. You also notice coming in, there's Barbados, large circulation trying to develop here, and everything steered around this high pressure area. You can see in that sort of tilt, everything's lined up. You never know what's going to happen. We're talking days out. And then if we just progress this out, this is day 5. Now we go to day 6 right there. Whatever this is in the Gulf, go back in time, moves inland, maybe Mobile towards Alabama, or Mobile is Alabama, into Mississippi. We'll see. So finally at day 7, the modeling indicating something trying to come together here in the vicinity of the Greater Antilles. The details will be worked out later. What I want you to look at is, think of this as the symptoms of you're getting ready to get the flu. You start feeling things, okay, I might be getting sick. But you don't panic and say, oh, I've got pneumonia, or I'm going to die in 3 days, or whatever. All right, I feel these symptoms coming on. The modeling is guidance, showing us the symptoms, if you will, a foreshadowing of a possible uptick here in the next week, 7 days out. If we go back to the beginning one more time, right here, watch how things progress, as we scroll through from day 1 through day 7 and a little bit beyond. So yes, we need to be paying attention to the system down here and where it ends up, and to possibly what's coming in towards the Lesser Antilles. And I'll certainly be on top of that, of course. All right, friendly reminder, I am on Patreon. This is more than just crowdfunding. It's more than give me money and I do stuff for you. That's not what that is all about. I am not selling a product like you buy from me something and it just goes on and there's no interaction. This is a way to make stuff happen. It funds what we're doing, yes. It helps me to support my family, yes. But the interaction is incredible. And we're closing in on 300 supporters now. We started at 0 a couple of years ago. Now we're up to almost 300. And there's been an evolution over the last 15 years of how we fund our work. And we are in the age of crowdfunding. And I just wanted to show you a little bit of some of these posts. Most of this is public, because most of what I do, I want to be able to do for the enjoyment and the benefit of the greater good. But I got to be able to pay for it. So becoming a patron, a supporter of our project, enables us to do things that are remarkable. As an example, this is the video from our GoPro that I set up in Rodin. Not quite. We did have one there, a live cam. This is the GoPro that was set up in Buxton. And our patrons made this possible. This is out there near a restaurant called the Fish House. It's no longer open. You see the Pamlico Sound over here was pushed out because of the wind coming from this way on the front side of Dorian. This is the eye of Dorian right here. There's my Tahoe. And then I left, of course, because bad stuff was getting ready to happen. The eye has passed. Now you see the water slowly start to come in. And then all you know what breaks loose. This is remarkable. And I'll show it to you for a couple more minutes here. It's remarkable because it's almost 100% directly because of our patrons. They benefit from being able to see some of this live. This GoPro is not live. I put these GoPros up in these specially designed boxes, and they record just like what we did in Mexico Beach. And look, you can see the water really coming back in with onshore flow now, the gravity taking over, the Pamlico Sound, which was once pushed this way, now gravity's taking over, plus the wind forces on it, pushing it back in. The surge comes in with a vengeance there, and I am well away from this area. I'm not going to sit out here and film this. You can't. You could say, well, go up on that balcony up there, film it from up there. All right, well, let's watch it for a couple more minutes and tell me if you think that was a good idea. really remarkable being able to see this from the point of view practically in the Pamlico Sound. Really, really incredible to be able to do this, and it's because of our patrons. Literally funding or buying equipment, it's very, very important, and I'm going to talk about it once in a while because it's making stuff happen, and I really appreciate it, and here's the fruits of that labor. You know, people opening up their wallets and saying, I'm willing to support this. This is what we do with that. So if you're ever interested in supporting something important, here's your chance, and look at what we can do with it. Nobody has ever seen storm surge from the Pamlico Sound like this before. And that's not some kind of an arrogant statement. It's just using the technology to solve a problem. So we can see what happens and watch it going forward. Now watch as this goes on. It's just a couple minutes longer. Surge gets higher, and you notice there's a few things that are very positive about this. Elevating the structures works. I mean, this is pretty darn close to being to the water if you ask me. But, you know, I'm not here to judge people. So you see, yes, mitigation, elevation works. And it's not just with the structure. As the waves go on, they start hitting the camera box, and it turns the camera around the pole, which actually was beneficial because we get to see more of this house in just a moment. Look at these boats back over here. They start to float. They were moored and anchored, presumably on high ground, but it wasn't high enough. You know, the water came in 5 to 6 feet above ground level. You see the water hitting the camera box, and everything's inside nice and protected. Look at the AC unit over here. You'll see it come into clearer picture in just a minute. This is where mitigation does work. In some instances, you know, you get a Hugo or a Michael or whatever, and there's only so much you can do. But, you know, I don't know if it was high enough for this surge event. It's got salt water all over it. Yeah, that's not good. But a lot that can be gained by seeing something from this perspective, using it to educate the public in the future. What does storm surge look like? Here you go. You know, the Hurricane Center benefits from this because it helps them understand if their forecasts were right, so forth and so on. And that, my friends, is because of crowdfunding. Patreon. Check it out. I'm also on Twitter at HurricaneTrack. And as always, I appreciate you tuning in. That is it from me for today. I am Mark Sudduth, HurricaneTrack.com. Thanks as always for watching and listening from whatever device you happen to be doing so from. It's great to have you aboard. I'll talk to you some more tomorrow.